So, thank you all for coming for this talk. This is obviously about security, and we'll talk about what I call a gatekeeper, which is named behavior analysis, or how could we strengthen at its maximum level our security in our production platforms. A little bit about who am I. So I'm Rachid Zarouali. I'm French, actually, from Lyon. I built a company of one, so I'm a freelancer, and I'm offering my services to each and any clients you have on the slides, Twitter, email, website, LinkedIn, blah, blah, blah. Wherever you want to reach me out, please feel free. I'll be really happy to share with you all the knowledge that I have, or share a beer, why not? So what I'm doing, a lot of stuff. I try to offer almost everything related to cloud computing, either if it's on-premise, on Azure, Google, AWS, OVH, Scaleway, whatever. And on top of that, having a global overview of all the needs for the projects, like containers, Kubernetes, obviously, infrastructure as code, CI/CD, performance monitoring, a lot of stuff. And just aside of that, I have a few, let's say, community topics, because I run different community in my city, where I organize events and gather speakers. And obviously, I'm speakers because I'm here. So, to introduce the topic slowly but steadily, where are we in 2022 about security? This graph shows briefly what we tend to have, a perfect CI/CD systems that helps developers in building their applications, testing the application, making unit tests, performance testing, security testing, full deployed automatically, and either if it's on a Kubernetes platform, virtual machines, app services, or whatever. This is where we want to go on each and any project, where we can say, okay, I'm fine. We made all the gatekeepers that we need. We built them. And when we deploy a version of application, we're safe. Reason is, we don't want to have to deal with deprecated libraries, vulnerabilities into our application before pushing into production. We want just to make sure that everything is safe. And once we push into production, we can then say, settle down and say, hey, cool, we deployed in production, everything is in green, so we did a good job. On another aspect, we want to add another level of controls or security. This is more about, let's say, DevOps world, DevSecOps world, in a way that on top of this secure supply chain, we want to add few controls that will live into our production platforms. For example, what we have here is how we can make sure that images, Docker or binary application is immutable, has been signed by our very own system, and making sure that our production platform can't pull or deploy anything that hasn't been signed by this topic. So we are a little bit further. We can go into, for example, in Kubernetes, we can go into security context, read-only file systems. We have admission controllers that helps into checking everything bits and pieces during deployment. We want in 2022 to make really sure that what we deploy is completely safe. No vulnerabilities, no, let's say, authentication token that has been left into different files, no outside communication that we don't know about, all of that. If we succeed in this, if we have the luxury, the ability, the opportunity to build this, then we might think that we are all safe in our projects, which means that we build a shiny new fortress around our application, this fortress works. Nobody can, oops, a little bit of power issues. Anyway, we'll deal with it. And we just want to have a single point of contact to have access to our platforms. Whatever runs in the platform is safe. We built it. It has been secured, has been tested. We're good. If I can I just will have a battery issue in the next minutes. And I don't know why. I wasn't.
Try this corner here.
All right, now it should be. Good. Sorry, glitches, live. So that's where we are. Our fortress, our applications is perfectly safe. Nobody can enter this fortress without going through all the gatekeepers that we built, and nobody can deploy whatever the application you just want without going through the CI/CD, and the CI/CD system and all the controls checks everything. We might have missed something. Let's see if some of you have found out in the previous slide, but perhaps building the fortress nowadays is not enough. Perhaps we still left some gates, means, context to leave hackers or bad behaviors people to get access to our application, and perhaps worse, to get access to the very own platform where our application works. So this is the previous slide. If you haven't seen it, we have this, because in this case, we are up in the mountain in 2022. We know how to create bad thing that flies high and fly far away that can destroy everything at once. That's where we are. We build a fortress. We have a single point of access to our application. We build gatekeepers. We have all the security measures that we wanted at first. We just forgot something. Most of the time nowadays, when someone wants to get access to your application or get access to your platform, it won't go through the infrastructure itself. It will completely leave your CI/CD system. He or she will try to find another way to get access to your platform. And obviously, the best ways today are the very own application that we built. So why is this happening? Why is this so bad little things living up there and jeopardizing my shiny new fortress that I've been built for years? There's a lot of explanation. Perhaps, when we deploy application, we just let them leave without updating them, or without updating them often enough. I have some example in mind where application has been perfectly built at once, perfectly tested at once, no worries about that, has been deployed, everything is green and working, but the application has been touched, updated for years. We built securely, we deployed securely, but we haven't managed our application. And that's the same for infrastructure. This example that you have here, I've seen it in production. I won't say where, why, who, but I've seen in 2022 regarding Kubernetes platforms run 1.15 in production and completely open. Again, when this was deployed, it was the state of void. No worries about that. There wasn't any questions about have we made the wrong choice. It was the right choice at the time. The real problem was it was left aside. Of course, we could have internal bad behaviors. What I mean by that is perhaps in the companies you're working in or in the companies that exist around the world, we may have people that somehow want to jeopardize the application, trying to find bad ways to control the application or make the application behave not exactly as it has been built. We've seen recently protestware. The example that I have here is probably one of the worst. There was one of the very famous NPM package, you probably heard about it, that has been changed very early in the Ukraine-Russia war, and the maintainer changed how its own package behaved. The modification was very, no pun intended, very sneaky in a way that this package will try to wipe hard drive for each and any machine that has an IP address which is from Russia or Belarus. This package is widely used, heavily used in many, in I guess 100,000 Node.js projects, and nobody checks that. And seems like there were a lot of computers that were completely wiped, which is another issue. But these are quite of the few examples that explain why this rocket here can happen at some time and break everything, even if you build the perfect system, even if you build the perfect CI/CD, even if you have the perfect Kubernetes cluster or the perfect virtual machine platforms, whatever. There's always somewhere a gate that you missed, and this is where we have, in 2022, and in the upcoming years, have to work on how we can close these gates, or at least how we can detect them and mitigate them. Very bad examples. The Log4j, I won't go through it. You may have heard it a lot of time during those 3 days, but it was one of the worst. And this case was hard for me, as I had some friends that spend weeks, days and nights just to fix their application completely in the rush. Again, there's no issue in fixing application. The real issue here was those applications were fixed in the rush. Meaning we don't have time to see exactly if we have the way to change the model or make things right. Fix it, whatever. We have tons of applications, just fix them. Another one is a dirty pipe, and this one is very interesting in the way that so Log4j allows you to trigger external access and deploy blah, blah, blah into your Minecraft, perhaps, server or the application that uses Log4j. Dirty pipe is a little bit funnier. This allows container escape. This clearly allows a bad user to get control not only on your application, but the whole platform at once. So how to fix them? Usually, when we see those ODs, those critical vulnerabilities, we just want to have a simple fix. We just want to fix them as fast as we can. And that's what we want. Because we don't want to deal with rewriting half of the application. We don't want to deal to rebuild the whole platform just because of this. So we just tend to, OK, what's the fastest fix? What can you do to fix that very easily, no matter what? Fix this. And again, in most of cases, what we see is bad fix. Log4j, again, is a good example. Since the very first declaration of the vulnerability, we see, I think, 3 or 4 others that came right before, just because the patch probably has been written a little bit too fast. One way, and this is where I would like to walk you through, is behavior analysis, which is completely different of building a CI/CD system with controls or building the perfect infrastructure. We just want to go here in a deeper, higher level to perhaps try and fix or at least mitigate those bad vulnerabilities, especially in the case where we are completely in the rush and we don't have time to write the application or rebuild everything. So what's behavior analysis? This is the official Wikipedia explanation, but in our case, or in the case of this talk, We'll talk about more about Kubernetes itself, and this is a way to keep a constant check of everything that is happening in your cluster or in your production platform. What we'll see here doesn't really apply only on Kubernetes, but it could be applied on virtual machines, bare metal, whatever. Rather than keeping a constant check, we also want to detect those abnormal behaviors. We want to make sure that those behaviors are keeping checked and we have a clear view of them, perhaps mitigate them, but at least we just want to know that bad things happen. In a nutshell, what we want to do is collect data, analyze them, if we can notify, which could be useful, and at some point, if we have the luxury, mitigate them, either manually or automatically. Are we able to build something that has a clear overview of what runs into our cluster or our application platform and can automatically behave depending on rules that we share on configuration and say, hey, you know what? This is not how this application should behave. Let's, I don't know, cut the tide, drop the container, reboot the application, or simply lock it down. I'll try to show you different ways to see that, and this is where we want to go. So basically, what we want to build is close to something like this. We have a fortress, we have one way, and we have to build something on top of it that protects on everything that could happen. Everything. Not only outside or from the outside using your CI/CD or your HTTP API, but more about getting access at some point to the application and change its behavior. This is what we want to look at here. Another way, what we tend to see is most of the hackers or people that have bad behaviors clearly don't care about vulnerability scanning, unit testing, code coverage, blah, 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 blah. They just want to skip them out and get access directly into your application. And by getting access to your application, whatever that means, change its behavior slowly, steadily, just to stay below the known thresholds. One of the use cases that we see is application that has slightly changed just to stick to the minimum resources needed for the application, so that if you look at graphs from Grafana or whatever, you won't see that this application is doing something else, because they get access to it, they learn from it, and by learning, they say, okay, we have to make sure that our crypto miners, for example, just stays below those thresholds. The tool that I want to walk you through is called Falco. This is an open source tool. I'll tell you more about it. And this is one of the tools that exists in the open source community that helps into keeping a constant check of everything that's happening in your cluster. Either the nodes, the Kubernetes itself, your virtual machines, Apache, MySQL, blah, blah, blah. In a nutshell, what is Falco? This is a behavior analysis tool, obviously. You have the link into the slide. And this project is supported since, I guess, 2 years now by the CNCF. So there's a lot of people around that uses it and contributed to it. And this is, again, one of the tools that will help us in this demo, if the demo gods are with me, to mitigate some example that I've created. How does it work? Basically said, Falco will gather everything, syscalls, Kubernetes API, whatever the service that exists in your platforms, kernel calls, and so on and so forth, and just gather them into a single point where we have a rule engine. I'll walk you through a little bit about that later on. And this rule engine is where the magic happens. This rule engine is where we keep a constant check of everything. What Falco offers is also the ability to trigger external notifications. We can write into files. We can go through a friend here, which is Falco Sidekick. Sorry, we'll see that HTTP, share, gRPC file, whatever. We have a lot of ways to offer to this tool means to notify and perhaps again mitigate. Deeper on how it works, it connects directly to the kernel. It uses extended Bucket Packet Filter, eBPF, and it gathers everything at the very low level of the kernel that happens into your host. So not the host itself, but all the application, network connections, files access. Everything that happens in the system is gathered, centralized, gone into this engine rules, and processed. What you have on the far right is how we can leverage this to do notifications using Prometheus, for example, or webhooks, shells commands. There's a lot of ways, and again, I'll show you briefly a few examples of them. To summarize what we've seen, basically we take everything, logs, syscalls, APIs calls, network connections, files access, Kubernetes events, everything, we gather them, process them, and depending on the rules and depending on the configuration that we push to this Falco tool, it will then trigger or not notifications again, and perhaps mitigations if we have the ability to. What we see here today is what we have on the top. So we'll see Falco, I'll show you that, and we'll see Falco Sysgate, which offers a UI where you can see those notifications, where you can see everything that the tool has gathered, the events that the tool has processed. We'll see also how we can connect it to the outside world, Slack perhaps, emails, webhooks, and see if we can somehow use some different plugins to do, let's say, shinier stuff. What's very interesting here, again, rather than only gathering events, is we have the ability to gather not what exists or what happens on the host, but on the overall platform at once. You don't necessarily need to get stuck to Kubernetes or only virtual machines. You can mix them. You can do just whatever you want. And we have here the ability to concentrate everything that is happening into our whole production platforms and process them again at once. So we don't have to say, OK, I'm using Kubernetes, so I have to use whatever the tool. Oh, now I'm using virtual machines, so probably I have to configure anything else, fail ban again, or whatever the solution, and just add something on top of them on each other. We have something that goes everywhere at once, gather everything at once, and help us to really have a full control of what's happening, again, in the overall system. So how to mitigate? Two examples here. The good way, well, the good side and the bad side is, so people that were used to Falco when Log4j happened were almost already protected. These rules that you have here are some of the out-of-the-box rules that Falco offers. I haven't written them. They are basic, somehow, rules that the tools offers when you deployed it. So how it works, you have conditions. Those conditions triggers outputs, and these outputs can be sent to your Elasticsearch, to email, to Slack, to webhooks, or whatever. And we have this priority notice. This priority, notice here, is a way to also help the tool leveling how critical the event that has been detected is, and perhaps do something else. So the example that you have here detects the launch of suspicious network tools that shouldn't be here. It is the first part that you have over here. And the second part detects that we have launched a remote file copy. We ask the application to get external file and then copy it into its own file system. And those two rules, and others that exist, allows you to efficiently detect this Log4j vulnerability. So what's missing here is probably how we can mitigate that automatically. Now that we have the rules that says, okay, there is something bad that is happening, it's related to this Log4j module, what can we do? Speaking about dirty pipe, this is, again, another way to mitigate it. And again, this is one of the very few basic rules that already exists in Falco. We have the same behavior. We have this condition. Here, the condition detects changes into your, file properties, detecting the usage of SID and SGID, sticky bits, and again, trigger notification. And again, this was already here. What's interesting here in those two examples is for those who face these one or two, let's say, bad adventures, you didn't have to go through the whole process of fixing at once, completely in the rush. You have the ability to detect that, what's missing here, and again, I'll show you afterwards in a demo how we can do that. What's missing is how we can mitigate that. But we had the ability to get notified that something bad was happening in the application, even if the application has been deployed 3 days before, and again, the CI/CD system was all green. I'll walk you through a quick demo about this. We have time? Yes, we have half the time. Awesome. Before going into the demo, I just want to walk you through in what I'm going to show you. So this graph shows everything that has been deployed on the platform. I'll show you right after that, and how it behaves. So basically, it started on the upper left. So there's a pawn pod, which has been detected by Falco. Falco push this event into Falco Sidekick. Falco Sidekick here goes to notify Argo events, which is a tool where you can program automatic events regarding notifications. Falco events push that into the workflow. The workflow triggers different rules, and in this case, the rule is destroy the pod. So each time a pod, in this case, is detected to has been pawned, depending on the rule, we'll simply drop it up. And as you can see, there are a lot of tools. Falco, Falco sysdig, Argo events, Argo workflow, all of them are deployed using GitHub's famous tool, which is Argo CD, if some of them have uses it in the past or nowadays. Let's go to a demo now. So this is my cluster, obviously, and as you can see, I deployed a bunch of tools. We have obviously some Argo, we have the Sidekick, we have a front end, Redis, blah, 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 WordPress. We have WordPress. Let's play a little bit with it and show you what could happen. Let me just fire up this small virtual machine. Shouldn't be here. Okay. So we are in the case where I hacked a shiny new WordPress that I built. Here I had the ability to crawl it because it doesn't have any security measures and find admin logins. So what I'm going to try here is, now that I have admin logins, can I briefly and swiftly get access to not the application, but its pod, and perhaps using reverse shell. So I started a netcat instance here that listens in the port to 8000. Let's make it up a little bit bigger. And now let me try some of the tools that exist and plays with WordPress. So this tool basically connects to my WordPress with a username and password and tries to open a reverse shell on this address IP and this port. Okay. Cool. So what do we have here? I get access to it. I found the admin. I found the backdoor. I've uploaded it. And now I had the ability to trigger some reverse shell, which means that if I go here, I got access to the pod. Woohoo! So starting now, I can play with the app. This is, again, from the external view. I'm a developer, I have access to the cluster, but perhaps I shouldn't play with it. I should play with the application directly into the cluster. If I want to modify the application, perhaps I just have to go through the CI/CD system, commit modification, and let the CI/CD system play. But again, if I want to play with it in bad ways, what happens if I do this? And again, I can trigger this and do this, for example. And let's see what happens. Come on. Don't break. Go ahead. Okay. So I have access, I'm root, I can do anything. Good news is, again, I deployed Argo, Falco, and it's psychic. So what happened here? Guess what? This has been detected and notified in my Slack channel. This is the example that you have here. This is a Slack channel I brought for this demo. So Falco detected it and pushed notification automatically into the Slack channel. So I'm notified. I'm notified that someone triggered a terminal, and I'm notified that someone tried to deploy into the pod something that shouldn't be here, which is the first step. Okay. Now, can I really mitigate that automatically? What I will do here is I'm going to go to my Argo CD overview, and again, this is Falco, so the tool I'm talking about, Argo workflow, and the event. So what I'll do is I'm going to go to Falco, and to show you a little bit bigger, this is the overall deployment. And I'm going to change here let's do it that way, go to master. Okay. Now let's go to Argo events and see if I'm on the right plane. Okay. So how is it configured? This terminal shell container is where the magic happens. In this case, where are you? There. This is where the event is triggered, and you have the source, which is a webhook, Falco, and it triggers on some very specific value. Here, it's the title of the rule. So it looks at the title of the rule, and if it sees cookie-tempered detector, then it triggers something. What could it trigger exactly? Let me show you. This is what you have here. This is falco event. This is the terminal shell, and this is what exactly it will trigger here. It will simply, or try to, delete the pod each time this cookie-tempered rule is triggered. What I want here is to try if I can lock someone that tries to get access to the terminal, so the shell of my application. So I'm going to go into Falco. Here again, change the branch, deploy everything, and let me show you how it works here. And these are the rules that has been loaded in my case. The one that we were looking for is this one. Terminal shell in container, priority critical, and this is triggered each time that someone tries to open a shell into this pod. This is the rule that should trigger the notification. Again, let's, where are you? Oopsie. Let's now say to the events also that we want to use the same rules. And let's go to the workflow as well and do this. And let's see if the demo gods are with me. I should still have the notification, and we'll see if the event works. As you can see, it has worked because you have those green bubbles here. Let's see if it works now. So let's drop this one. I think I can, yeah, I can kill this one. I can kill this one. And let's change whatever, this one. And okay. And what happened? Boom! I've been dropped. What happened exactly is this. This pod has been automatically triggered because, in my case, Falco says when these rules apply, trigger a notification. This notification gone to my events, and the events here is configured to look at this rule. And if this rule, which is the case here, is named terminal shell in container, then it will trigger the event, and the event, as you saw here, is destroy the pod. This is one of the ways that you can use to somehow mitigate. Dropping is not really mitigating, but this is an example of how you can mitigate. Basically, you can do anything. You can, of course, drop pods. You can apply automatically network policies that cuts the tide. That would be really useful in the case of Log4j. There are plenty of solutions, and the use of Falco ecosystem connected to the Argo ecosystem makes really a great fit into that. Let's push my luck a little bit further and try something else. I've deployed a Redis here that we have. And this Redis has been deployed using root-only file system, meaning that I can't get access to it. So let's move into the next step. I'm doing this one to go on each and any step. Moving to master, where master is clean, in my case, no rules. Okay. Go to Falco again. And master. Okay. So now I should be able, to do this. And I should be dropped. Works. So I'm on the shell. If I do touch me, as you can see, read-only file system. I get access to it, but I can't modify it. OK. A little bit of issue here. If I do this, this is a 5.0.7. Just get that in mind for a few seconds. And let's try something different. So I'm connecting to the local here Redis instance. I'm going to get my cheat sheet because I can't really write it down at once. Just to show you again, I have been detected here. But as I've disabled all the mitigation, I'm just notified that someone, again, get access to my WordPress and actions and also the Redis. So now let's play with this and see how it works. What you see here is how we can use a vulnerability that exists into this version of Redis that uses sandbox escape because of this version of the Lua plugin that is used by Redis. So I'm on a root file system, read-only, but I still got the ability to download something. As you can see here, I did a wget on dev shame. And if I go to dev, if I go to dev shame, I have files, which shouldn't be here. I'm on a root file system, who's on read-only. So I just use the vulnerability to sneak it out. Let's now do a last demo and see if I can do exactly the same. Falco, workflow, devshm. There we go. Events, devshm, and see how it goes. Let's close this one and reopen a new one. Still got access to it. Redis CLI. And now what happens? Yoo-hoo! We'll see in a few seconds that I've been dropped. It's just the time. So it has triggered this delete pod, which is successful, as you can see. And just because it's a demo, it will take some time. Yeah. Anyway, the pod has triggered. That's it. That's where we are. So this is a bit of an overview of what happened. And again, I have notification here. Funny thing about this Falco sysdig sidekick is I have a UI here that I can use, easily deployable. And I can go to sensitive informations. For example, I can go briefly to critical and see if I had some critical behavior that has been detected. And I have one here. If you don't see enough, let me make it big enough. And if I do this, yeah. This example shows that Falco has detected my usage of this vulnerability. And as you've seen right after that, it triggered the automatic mitigation. That's it for the demo. And it works, which is nice. If you have any question about the talk, the tools, how I built it, or whatever, we have 6 minutes left, and I'll be more than happy to answer them.
Hey, is there not a risk with this kind of behavioral analysis and auto response that your security program can become a denial of service? So
It is, definitely. This, again, this is a quick demo, and you're right. You should not deploy them blindly and have, let's say, full faith of what it's getting. Get to know exactly all the rules that it has loaded. In this case, I dropped all the by default rules, and I just get the ones that I wanted to use. As I said before, this tool comes with a bunch of rules, many of them. And yes, if you don't know exactly how those rules behave, you can, without really willing that, you can break your production. Yes, indeed.
Thanks.
The fun fact is, as it loads a lot of rules, it should, at some point, help you, let's say, rising your security level rather than crashing your app. But yes, it can happen, definitely. Any other question? Who discovered Falco? Who knows before this talk that this tool exists? Raise your hand, I won't bite. Okay. Who learns something from this talk and is willing to deploy it, perhaps, into production? Nice. Again, word of advice, and that's what we said. Don't trust the tool blindly. Take your time. This is a quick demo again. Argo CD is doing a lot of automatic stuff for me here. I just have, as you've seen, click here and there and change things. There's a learning curve in this kind of tools, and more importantly, it's not because you just deployed the tool that, again, you can sit back, relax, and sleep. The tool itself loads its own rules, and you have, in the open source version, have to review them and update them. If you move to the, I haven't talked about it, but if you move to the SaaS version of Falco, it loads automatically new tools that are pushed into the SaaS versions. So it depends on where you want to go. If you want to stick with it on your own, go for the open source solution. If you want to be completely managed with new rules, some rules that I've showed here came automatically to a lot of people that use already the SaaS version. Depends on your needs. Just take your time and don't rush for it. Okay, thanks for coming, and I hope you enjoyed this talk.